Visualizing the engineering project lifecycle. G'day everybody, my name's Michael Gardner. I am the real-time technical lead for Aurecon, an engineering consultancy. Now, Aurecon doesn't have a very much of a presence in Europe, so I understand that a lot of people might not necessarily know who Aurecon is. So I think first things first is I'm just going to establish a little bit of context. So Aurecon is actually a global, I say global, we don't actually operate in Europe or the Americas, but we have a very large presence, particularly in Australia, New Zealand, and South Africa. So we're a global multidisciplinary engineering consultancy, so we do all types of engineering. We've got 7,000 staff, 80 offices. We've actually been offering visualization as a service now for over 15 years. For us, that's really interesting because especially when you go back 10, 15 years ago, visualization was normally nothing that would ever be done in-house in an engineering consultancy. I mean, we would just subcontract that work out. Aurecon made the decision to invest in their own visualization team, of which I've been a part of for 15 years now. We have been looking at real-time for a very long time, since the mid-2000s. I'm not sure if anybody remembers back then we had things like Quest 3D, that terrible node-based real-time engine, or RTRE, which is the real-time rendering engine plug-in for 3ds Max. We tried a lot of different things. Being an engineering consultancy, Aurecon is quite heavily Windows-based, simply by virtue of the fact that we use a lot of CAD software, which is just not available on the Mac. So I could always see kind of Unity off to the side. It was Mac only back then. It was super frustrating because I used to look at it and say that, you know, that's exactly what I want. We just couldn't get it. Suffice to say, when Unity released 3.4 and it came out on Windows, we jumped straight on it, grabbed a couple of licenses, and we've been on the journey with Unity ever since. Now, earlier this year, in 2019, I think it was a few months ago now, we announced the formation of Unsigned Studio, and that came about through an acquisition that we made in Australia. If anybody has heard of a visual effects company called Squint Opera, there was a Melbourne franchise of Squint Opera, and they made the decision to break away from the Squint franchise, and then shortly after that, Aurecon acquired them. So they joined, combined with the existing visualization team that we'd had for the last 15 years, and we now refer to ourselves as Unsigned Studio. So what actually is Unsigned Studio? Put simply, we are a 3D visualization and creative technology studio. We're basically a small group that sits inside Aurecon. So we're still very much part of the Aurecon business, but we also have the remit to go outside of Aurecon to win work that is independent of Aurecon as an engineering consultancy. We combine engineering, technology, and visualization to make some really cool things. You can see that I've listed some of the areas that we play in. Predominantly, most of our work is still in that kind of high-end rendered feature film and image space, although increasingly we are moving into that real-time space. I think at the moment about 50% of all of our delivered projects are basically delivered through the Unity software. And so for the talk today, we're going to mostly focus on the things like the apps and the platform side of our capability. It's always better to show what we actually do rather than just talk about it. So here is just a very short 1-minute technical show reel of So as you can see, lots of cool stuff and lots of very different things as well. So to take it back to engineering, engineering is hard, and every year engineering gets exponentially harder. Some of the reasons for that is that we're now dealing with larger and more complicated projects that are often multidisciplinary, everything having to come together. We work with much larger teams. They're quite often globally distributed. We are becoming an increasingly risk-averse industry. Risk management is now playing a huge part in any engineering consultancy because there is an increase in litigation. I mean, behind the scenes, like, everybody is just taking everybody else to court. It doesn't seem to affect anybody's relationships. I just think that's just business as usual. There's all these different ways of working. There's things like BIM and PIM and IoT and all the acronyms. There is a huge external pressure to get it right because the consequences for getting it wrong can be massive, not just from a financial perspective, but also like reputational sense as well. So how can we use smart visualization technology to try and improve things or help things in the engineering industry? So just a snapshot of a few things that we could potentially look at. We could, evaluate multiple design options. We could interrogate models for that BIM metadata. We could perform clash detection. We can connect dynamically to all sorts of databases, whether that's asset management or BIM. We can actually create bespoke engineering tools to solve specific challenges. And this one really speaks to the flexibility of Unity and the fact that we can really almost build anything that we want. We can view and interact with super dense point clouds. We can do sunlight and shadow analysis. We can do that virtual end user testing. So actually putting the ultimate end user, not just a designer or a stakeholder, but that end user of that design into that design in virtual reality to make sure that it is actually fit for purpose. And here at Unsigned Studio, the way that we tend to deliver our visualizations is through a framework. So it's the second definition there, the skeletal, openwork, or structural frame. And what that essentially means is that every time we deliver a real-time visualization to a client, it's done through the same framework. So it looks the same, it feels the same, it has the same level of functionality, and it means that we don't need to reinvent the wheel for every project. And potentially even more importantly, it means that we can start, as a business, we can start to build a brand around our framework. These are some of the other benefits. So it introduces the concept of a single visual language. It means that we can rapidly spin up projects. We can iterate through designs a lot faster. Again, everything has that consistent look and feel. We enforce minimum standards of visual quality because it's actually baked into the framework, so you don't really have a choice. It's a robust base for all sorts of future expansions that we want to build on through the use of extensions. And then again, those two at the bottom are so important. It's about building your brand, and it's becoming a key differentiator for you against your competitors. So SiteLab by Unsigned Studio. SiteLab is the name of the framework that we have created. And basically, it's it has a nice, accessible front end. It works across all devices, desktop, mobile. It integrates VR directly into it. So if you have a VR headset plugged into the computer, it will automatically register that and give you the option to drop straight into VR. So it's kind of VR by default. And it has a whole bunch of editor tools and workflows. I'll quickly show you a video of what so this is the front end. This is what SiteLab looks like that we would give to a client. So you can see that it's like a fully kind of interactive environment. We've got a bunch of menu systems that run along the top and then down the side. So very quickly, the top menus might be familiar to people that work in CAD. So we have things like layers, and not just layers, but also isolation, nested layers, parent-child layer relationships. We have a bunch of different camera types. This particular project's only got two, the free-flying camera and then a first-person camera where you can drop a pin down into your model and then suddenly you're there to walk around. Again, if you had a VR headset plugged in, it would automatically add a VR camera to your camera drop-down list. We have the concept of extensions, which I'm going to talk about in detail a little bit more later, but basically it's where we start to build kind of big like plugins that bolt into the side of SiteLab. And then the menu system down the left-hand side, we've got the project location, and then we've got like an accurate time of day system where you can basically look at any day or month or year. and then also have a look at different weather conditions as well. We have also linked that up to live weather for certain locations. And in this particular project, we've got it so that the people, the makeup of people in the station changes based on the pedestrian simulation that was run for this project. We also have measurement tools, which is the next one. At the moment, it's pretty limited to just sort of linear measurements in area, but we're building on that. And then we have screenshot tools where you can both take screenshots, you can either show the UI or hide it, make different size resolutions, and then also things like marking up the screen as well. So that's kind of what SiteLab looks like for the end user. That's what we would hand over to the client, like a single executable, which they can just run on their own machine at work, and that's exactly what they're going to get. But a lot of the smarts of SiteLab is actually the tools that we've built into the editor, and in particular, the big kind of project creation wizard that we've got. So I've got a couple of pictures here that I'm going to show you. So essentially, this is what it looks like when you start off with an empty Unity project. You open up the Aurecon package manager, which is something that we created before Unity announced their official package manager, hence to say it's now redundant, and we're just going to slot SiteLab into the Unity package manager the way that you can now. So basically, this is what the project wizard looks like. So you can see we have the concept of a build configuration. Everything is a multi-scene approach. So the cameras are in one scene, the environment is in a scene, the models are in a different scene. And the reason we do that is so that we can have these detailed build configurations where basically you say what I'm actually targeting, and then you just load the build configuration for that. And it might be that if you're targeting mobile, for instance, it's going to have a different environment scene than if you're targeting desktop because of compatibility. And then the next one over here is the project information, where we put in the basic project details. So we can put in the Aurecon project code. We can specify what the opening image is for that, what revision we're up to, who the clients are. We can put logos in, and just like lots of little quality of life things. So you can see that in the project image, normally, you can click on the icon where it says select, and it would bring up the Unity dialog box where you could select your sprite. But we've also built that import where it just kind of handles all that. So you just select an image straight off your hard drive, and it will convert it behind the scenes and bring it in there. The idea is that we wanted to try and lower the barrier for entry for anybody that wants to use SiteLab, not necessarily have to know the ins and outs of Unity. And then again, the same with the clients down at the bottom of the screen. Then we have the layer system, and you can see that it's basically where we set up all of those detailed layer relationships and the parent-child relationships. So the drop-down that you get in SiteLab is a one-to-one representation of what we put up here. The cameras is where we put all the various camera registers. We also have, you'll see the one down the bottom is an animated camera, and that's one that you can just basically switch to and hit play, and it will just play a predetermined camera path. So it'd be good if you want to set up in like a shopping center or something to demonstrate some sort of project. The cool thing is that it doesn't just use a simple animation. It actually runs off a timeline sequence, a playable director, so you can actually start to layer up some super complicated animations, not just camera animations, but when the camera's at a certain point, you can have the environment change and things like that could happen. Then we have the environment set up, again, where you specify the day, the time, but then also the project location, which is what drives that accurate sunlight and shadow analysis. And we've kind of hooked into like the Google search, so you can just type in the location that you're in and then just click on what it comes up, and it will automatically fill in like the latitude and longitude, which is very nice again. And then the last one is for those extensions. If we do have extensions that have options associated with them, then you can do that from right within the project setup. So, taking it back to the presentation itself, the engineering project lifecycle. Now, when I talk about the project lifecycle, I'm using a slightly simplified version of the flow of information through a project. So starting from the proposal stage where you submit your tender, then going through your design, your early concept design, and then your detailed design, through construction, and then into the asset lifecycle in things like operations and asset management. So the way that the presentation is going to run is basically we're going to look at these one after the other, talk a little bit about each stage, but then show you a case study of how we've used Unity to build some smarts and to get some better outcomes through each of those stages of the life cycle. one thing to note is that there are some projects that I'm not allowed to talk about what the project is called, who the client is, or where the location is, because they are still active projects with all sorts of confidentiality clauses around them. But just rest assured that every example that I'm going to show is something that we either have or are in the process of delivering to a client. Okay, so let's start. Project proposals. So, everything starts here. If you don't win that job, then this is where the story ends. You just have to win that project. And proposals are an incredibly competitive space. And in addition to that, companies are operating a lot more globally now. So there is now a lot more competition in local markets than there ever has been before. Wouldn't it make sense to give yourself sort of any advantage against your competitors that you possibly could? Proposals very much still exist in a paper world. I've got some images here. So this is a proposal submission that we did a few years ago for a big roads project outside of Brisbane. It's called the Toowoomba Second Range Crossing. It was delivered in 38 binders, and because you have to deliver multiple copies of that, we had to load it into these custom-made trolleys and put the whole thing in the back of a truck, like a lorry, and like drive it down to the tender office. It was absolutely crazy. I like to amuse myself by thinking about what a proposal might actually look like in 5 years' time, because it can't look like that, surely. Potentially it could look like this. It could be it could just be a branded app. A branded tablet. So you just give an iPhone, an iPad across to the client, and it's already preloaded with everything that they need for that proposal. All of the drawings, all of the reports, all the information, all the visualization, all kind of wrapped up into one nice package. It's nice to think about, but I guess until then, how can we use visualization tools? Maybe not to replace, but just to supplement that proposal process. So the first case study that we're going to look at is one that I'm not allowed to talk about because we're still actually in the proposal phase for this project, but basically it's a major road upgrade project. The city that it's in, there are all these different upgrades and resurfacing works taking place kind of all over the city. Each of the different sites, there is a bunch of different options that we've looked at to consider how we might go about staging the shutdown of certain lanes and the way that traffic is going to behave. So it's super important for us to try and make sure that the client understands that we have looked at every single area and every single option within that area very, very closely. The last thing that you want is for the client to think that you have maybe just kind of jumped straight to a solution without giving the actual problem the thought that it deserves. So this is the app that we have created that is going to accompany our proposal. So it's an iPad app. So you basically select the area that you want to look at. It runs you through a bit of an on-screen tutorial process because it can be slightly complicated. So, and again, the people that are using this might not have much experience with this sort of thing. So you run through this tutorial, and then you put into the live kind of 3D view. You can see we've gone for a bit of a stylized, low-poly approach, mostly due to the fact that we didn't have much design data at this point. So this is the roundabout, the area that's in focus, and you can see that all the lanes are open, but then on the left-hand side, you can start to switch between the different options, and then each of those options has different stages, and a stage is just one night of works. So for instance, this option has 4 nights worth of work, and you can jump to each of those nights and you can see what actually remains open, what closes, the traffic adjusts, and also the traffic that's in here is also accurate as per a traffic simulation. We actually recreated it and built like a bit of a semi-smart traffic simulation inside Unity. The other cool thing is that you can go to this separate view, which is the traffic redirection, because it's one thing just to close the roundabout, but it's another thing to understand what the implications are for the wider traffic. So you can see that, again, you can pick the different options and the different stages, but then it will actually show you kind of, because one part of the roundabout is closed, what is the preferred redirection route so that we can get an idea of what the redirection implications are. The other thing that you can see is on the right-hand side, we have this rating system, and this is where we've worked with the client to basically attach a weighting to all of those different criteria based on each different option, so they can use that to try and understand what the preferred option is. Okay, so on to stage 2, which is this design optioneering / early concept design. So we're going to assume that we've won the project. We've come up with a bunch of different design options. The question is now, what's actually the best way to go out to the community and start to engage with them around these design options? Now, traditionally, we would just go out there with a whole bunch of plans that look like this. If you haven't looked at a plan before, you're probably going to look at this and you say, what the heck am I looking at? This is a fairly detailed intersection upgrade with a bunch of bridges, but again, like, they're super difficult to read. And like, what if you're like one of the people that lives like along the street right next to the design? They might say, I don't care about this. I just want to know what it's going to look like from my house. Like, what's the visual impact? And we can say, oh, well, I've prepared this long section for you. And they would just be like, what am I looking at? Like, this is even worse. I don't even know how to read these things. It's absolutely crazy. So, can we not build a more engaging experience? Like, wouldn't it be cool if we could go out there with an interactive model and be like, well, it looks like this. And when we go down to perspective view, it's going to look like this. And hey, you want to go to your house and see what it looks like? Well, that's basically what it's going to look like from the footpath outside of your house. Clearly a much better experience. Okay, so on to the case study. So Sydney has a bit of a problem, and in particular, Sydney cyclists have a problem. Australia is certainly no Denmark when it comes to the adoption of active transport. So the problem that we've got is that if you want to ride across the iconic Sydney Harbour Bridge in any direction, you're inevitably going to come to that point that I've circled just there, and it basically looks like that. So you have to go from at grade to a 10-metre high elevated cycleway, and the only way to do it is like up or down a set of stairs, which leads to situations like this, which I'm sure you can agree is like absolutely crazy, like a terrible, terrible outcome from like a design, safety, like just terrible. So we worked with RMS to basically come up with an engagement tool that we could visualize all those different options, and this is where we look at a Sitelab extension. So what we did is we built an optioneering extension directly into Sitelab so that we could go out to the community and then go on to engage with the local community and stakeholders. And this is kind of what it looks like. So again, we're back in the Sitelab framework. So you can see that's the area of focus, that terrible set of stairs. But what we can do now is we can go up to the extensions menu, and you'll see that there's the optioneering extension. It gives you a whole bunch of all the different options. So these are all the different design options that have been considered. And basically, the client wants to be able to go out and show all these to the public and understand how they feel about them, gather feedback. So you can see that we can get right down at ground level, and we can toggle between those options. We can understand the visual impact as you approach this design. Then you can leverage the different camera types, so we can jump down into a first-person camera and understand what that's going to look like as a cyclist, so kind of directly at that point. So you can see there's the stairs, but then potentially it might look like that, which is clearly a much better outcome. Then the cool thing is that once the Sitelab model's built, we can start looking at a whole bunch of different ways that we can engage. And in the case of this project, the actual end user is a cyclist. So luckily, we've built this VR bike simulator, which we've used on a few different projects now. We use it to test cycleway optioneering and to validate our design assumptions. And it's super exciting because moving forward, we want to start looking at eye tracking. We want to look at capturing kind of detailed biometrics of the user, have audio, and kind of collate all this rich information and data that will ultimately help us make a better design decision. And that's, some of the other ways that we're using it is things like space utilization and wayfinding and navigation. So you can see we've got like a VR bike, we've got the VR kayak, we've got a train simulator, like a whole bunch of different simulators. All right, detailed design. So how can we use visualization tools and technologies to actually start to make better design decisions through the detailed design phase? And the answer is by allowing the flexibility for us to actually start to build custom solutions. And again, this is where Unity is so powerful, because it means that if if a client comes to me and says, I have a super specific challenge that I need to try and overcome, I don't need to look at my software and say, the software doesn't really let us do this, or we have compatibility issues. It just means we can sit down and be like, yep, that's fine. Let's just figure out how we can build this for you. So it allows us the flexibility to build these custom solutions to solve those really specific problems. And the example case study that we're going to look at for that is the challenges that designers have around rail signal sighting. And that's basically making sure that the train driver can actually see the signals at the minimum sighting distances that he needs to. At the moment, there's not really a super great foolproof process for doing that. And it's really difficult to uncover issues prior to actually constructing that rail line, which means that if there is an issue, they're going to have to go back and change a whole bunch of stuff, and it's going to be very, very expensive. So, the old way. Now, I don't know if you can see what's going on in this picture because they've photoshopped the actual signal on top of that. But basically what happens is once the design reaches a certain point, a whole bunch of signaling engineers, they walk along the site and they hold this pole that's got like a dot at the end. That's meant to represent where the signal is, and then everybody else kind of goes back 50 or 100 or 200 meters and makes sure that they can see it. I mean, as you can probably understand, it's like not accurate at all. And again, if you found an issue, it's like, mate, well, it's just too late. So a better way, and this is the way that we first explored, was that we would actually take all that data and federate it inside 3ds Max. Basically, the way that it worked was I would sit at my computer in 3ds Max, and I would have like 10 signaling engineers behind me, and they'd all be looking over my shoulder, and they'd be like, all right, now stop there, now zoom in, and now move that signal 10 millimeters to the left, and take a screenshot. And it was definitely better than walking the site, but it was still not super great. So that's like an example of something that is perfectly ripe for just automating and just building a tool inside Unity, which is exactly what we did. So we basically built a signal sighting tool set that was integrated straight into SiteLab. It just meant that instead of everybody coming up to my desk, I just handed over the file and be like, there it is, you guys go and have a play and figure it out. It allows them to drive the train and adjust all the parameters, but then the cool thing is that it actually saves all that to an external file, like a spreadsheet file, and that file is actually what becomes your single source of truth. So when you first load up the model, you're going to load that file, and then when you make changes, you're going to export it back out. It is then going to get passed back into the CAD software, and they've written a bunch of macros on that side that will then read that data and automatically update that design, so it kind of closes that design feedback loop. So the example that we've got, our case study, is the Caulfield to Dandenong rail crossing removal project in Melbourne. And basically it meant that signal designers and the rail operators, the actual drivers, could actually have a go and determine that optimal placement. And the other cool thing is that we could use the SiteLab time of day system to start to understand if there was any sort of environmental implications, whether the sun would rise or set directly behind signals, which would then inform whether we need to design kind of shrouds that sit behind them and things like that. And again, something that would be almost impossible to do outside of this sort of environment. So here we go. So we're selecting the area that we're going to look at for the project. And then straight away, the first thing you're going to see is this, whether you're going to create a new configuration file or you're going to load that existing configuration. So we just created a new one. This is a slightly earlier iteration of the framework, which is why it looks a bit different to the other SiteLab examples. But essentially, we've got this tool called the signal sighting tool. Now, there's a bit of stuff going on the screen. It can be quite complicated, but basically everything that's at the bottom of the screen relates to the train driver. So that's where you can determine the camera speed, essentially the speed of the train driving along the design, what your current chainage is, and then also what type of rolling stock, which determines the offset position of the driver. And we have two presets, or you can actually go in there and manually adjust that to basically cater for any type of train. And then everything on the right-hand side determines, it relates back to the actual signal. So where that signal lies along the chainage, what the different parameters are for the different heads, the A heads and the B heads. And then you can see here that what we're doing is we're snapping to those predetermined sighting positions that you need to be able to have adequate sighting to those signals. You can choose whether it has a theatre indicator, which is that speed sign, and what the information is. And then you can start to edit all that, and you can move all of those parameters and shift the signals around independently, the masts, independently of the heads, etc. So basically, the signaling engineer would sit down, they'd make a whole bunch of changes to all the signals. They would then export that data. It would then read back into the CAD software, and it would update the actual design. I think at the end of this video, I think I do an export just to show you that it is actually like it's a fairly basic format. Yeah, so that's basically what it looks like. So I mean, there's nothing hugely complicated going on, but it was quite effective way of tackling that particular problem. Okay, the next stage is as constructed. So we're assuming that our project, whatever it happens to be, it's been constructed. We've got a detailed design model and also now a physically constructed asset. So, is it possible to reconcile the two? Because, the design doesn't always necessarily reflect the ultimate end use of the asset. I mean, there's a pretty big difference between this versus this. And I'll just go back so that you can see. And obviously you just saw from that slide, this is where the power of point clouds comes into play. So point clouds is like a huge area of focus for us at the moment. It's super, super exciting. So it all starts with this viewer called Poetry. I'm not sure if you've heard of it, but it's basically was created by this guy, Marcus Schutz. It was like a diploma thesis. It's a WebGL-based point cloud streaming and viewing platform. It was started to get used in Aurecon quite a lot through our GIS team anyway. So then basically they kept saying, well, why can't we just take this and put it into Sightlab? So we bounced around with a few different ideas. We tried a few different assets for point clouds on the asset store to see kind of what worked and what didn't. We couldn't get the performance that we needed out of any sort of assets. So we thought, like rather than trying to take an asset and make it look like Poetry, like let's just go to the source of Poetry and just build our own. So luckily, like inside the diploma thesis is pretty much all the maths that you need to know to be able to do this. So we just went ahead and we built it. The requirements were that we needed it to work on the iPad. It needed to obviously be performant and to load not only local point clouds, but also to stream them directly off the web through things like Amazon S3, for instance. And for a few technical details, it's multi-threaded. We have a different loader, a processor, and renderer modules. It works across most popular devices, and we've now bundled it into Sightlab as an extension. So the example that we're going to look at now is, again, it's one that I'm not allowed to talk about the actual name, but basically it was a project that we did with the client to do a visual reconciliation of the design model against the actual physical utilization. Moving forward, we're going to use it as the basis to start building all sorts of cool automated tools that can actually start to quantify the difference between the design model versus the actual construction. And for the client, they actually used it as a pilot project as well for best practice for 360 laser scanning, which was something that they hadn't really had much experience in at that point. So here it is. So it's a big building. You can see that it's a very dense model. It had every service in there. But then the cool thing is that we can switch on these point clouds, and then suddenly we have this full point cloud scan. Now that's streaming in straight off Amazon. You can see it's like super fast. There is in excess of 10 million points in this particular project, but then it uses all sorts of crazy like Octree systems to only kind of pull in the data that you actually need. You can see here that we're kind of looking around, and then through the layer system, we can also switch on the design, and again, that's where we start to do that visual reconciliation of the design versus the actual construction. In particular, this is something that excites us a lot because every single project these days, at least in Aurecon, it has some sort of point cloud attached to it. And if you even go back like a couple of years, there was no way you could be visualizing like dense point clouds in this sort of environment and so performantly. So my response now is that I just want to be able to I just want to chuck point clouds in like every Sightlab model. Super, super exciting. I'm going to skip ahead now because I'm probably running out of time. Okay, so the next stage in the project is where we start to move into that asset life cycle, and this is the asset operations phase. So we've got a great model. We used it to do all sorts of cool things during the design phase, made all sorts of better decisions, better outcomes for the client. But I mean, what now? Luckily, there is still a bunch of different things that we can do to leverage that model, and we look at each of these very quickly. We can do things like we can build training simulations, and this is something that we built out of our Cape Town office, which was all to do with training for how to operate an electrical substation. You can see we have the billboard that you have to read the information. You pick up the mobile phone and put it to your ear, and somebody talks you through the process of what you have to do. It's super, super awesome. We can do things like health and safety. This is an example of an app that we built internally for Aurecon to kind of replace the onboarding process of health and safety. So rather than looking at like these terrible kind of tutorials where you have to like multiple choice, instead we put somebody in like this cool 3D environment. They find hazards, they have fun, they understand what we call our life-saving rules, which are Aurecon's kind of version of the OH&S rules. We can do site and building inductions. This is an example of the new Brisbane office that I work in. It's the tallest commercial timber frame building in the world. It's a super, super awesome building. Very, very different to our previous building. So a big part of that change management process was to get as many people through this kind of accurate VR representation that we built so that people understand what the building looks like, how it's going to feel, where all the different components are. Get people to sit at their virtual desk and understand how much desk space. Because we're told that everyone was getting slightly less desk space, and everyone just lost their minds at the thought of having 10 centimeters less arm space. But then once we actually put people through the VR model, everyone was fine because they understand, you got the controllers in your hand, you intuitively understand the scale. It made a big difference. And then we can do things like scenario testing as well. So this is the train simulator that I mentioned earlier, which we've been using to do things like understand what the procedures are if you have to do an emergency braking, or if the power goes out, or if something falls on the tracks, for instance. So the case study for operations is, again, sorry, I can't actually name it, but it is all to do with locating the cabin on a ship loader. So one of those giant machines that spits coal out into a boat and then it takes it away. It's a bit hard to see, but the cabin is the blue square that's on the left-hand side. And traditionally the cabin would be out on the boom, which is very unsafe, so they want to move it back onto the main structure. They just don't actually know where to put it. And normally what they would do is they would erect scaffolding and just get somebody to sit up there on like a deck chair and say, yep, this works, or no, this doesn't work, bearing in mind it's like an actual live piece of equipment. So that is like super, super unsafe. So instead we're like, okay, well, how about we just build the whole thing in VR? It'll be a fully operational ship loader. Everything will work the way that it's meant to, with the right constraints and speeds and everything. And then we can use it not only to determine where the cabin goes, but then also where we need to place all the various CCTV. Because, the fact is that they are going to have less vision than what they did. So we're going to need to supplement that with a whole bunch of CCTV cameras. So this is what we built. So again, fully operational ship loader. You can kind of control the whole thing. I've got it like sped up at the moment. It's because it's normally much slower than this. All the angles are correct, all the constraints, the way that everything moves. This was like a ton of fun to build as well. My technical artist in Brisbane, he is like so deep in the details that he was just he was in heaven in this job. It was awesome. This is what it looks like when you're actually inside the cabin. So you can see we've got the CCTV feeds coming in. It's all render textures. It's all live. We can move those together with the client. We can sit down and say, all right, well, where do we actually need to place these cameras? And again, you can fully drive it. That's good. And you can see that when you get down low, it actually starts to spill coal out as well, which they didn't ask for, but we don't really get an opportunity to use particles very often. We're like, no, we're putting that coal in. But the really cool thing is then that we built it in VR and actually tested it with the client. So a bunch of ship loader operators came into the office, they sat down, and I think we put through something like 15 15 operators in a single day, and everything is controllable through the hand controllers. And if you've used VR, then you know that it actually just that sense of scale and presence and visibility that you get is fairly accurate. So they could start to test where, the other thing is that you can actually move the cabins, because that's the whole point. So not only can you operate the ship loader, but then you can also start to move the cabin up or down, out to the left and right, and also forward and back as well. So all the operators went through, kind of let us know what they thought was the optimal position. We found the average, and that's how we proceeded with the design from that point. And again, like normally they would do this on a live ship, so this was a much, much safer way of doing it. Okay, the last stage that we're going to look at is the asset management space, which is actually like starting to become increasingly huge. The amount of conversations that I have these days about asset management is just crazy. So it really is the last piece of the puzzle. It's that kind of ongoing whole of life system. Like there are so many acronyms: BIM, AM, BMS. But at the end of the day, I mean, it is just all data. So what we can do is start to explore how we can create more meaningful interaction with the data, and in particular, how we can start to build these kind of really nice visual front ends that actually still kind of reach in behind the scenes and connect to actual engineering data. We don't have to bake anything into our Unity projects. That's like one of the great things about Unity. So, this is an example of a smart sensor app that we built for our Sydney office, which is picking up all the sensors over the network, and it gives you readouts of things like the light, the movement, and the humidity. And obviously that's a much nicer experience than just looking at it on a spreadsheet, for instance. The reason it's so easy to do this is because Unity does play super nicely with others. It leverages the .NET framework. It connects to all sorts of databases and APIs. It plays very, very nicely. And what that means is that we don't need to look at necessarily Unity as being the ultimate solution, but it introduces the concept of this rich ecosystem of apps that you can build that includes visualization, but isn't just all about visualization. So in the case of Aurecon, we have these apps called DrawingBox and FieldForce, and DrawingBox is a way to associate a physical item with a database, so it's sort of like a QR code that you would scan. FieldForce is then our on-site inspection report tool, and then obviously SiteLab is how we visualize it. And again, if we go back to the data, you can see that that's kind of where the data fits in. So DrawingBox is all about kind of getting that data and connecting it to a physical asset. FieldForce is then about capturing data and then making analysis, and then SiteLab kind of starts with the data and then builds on that to do visualization. And again, this is just a diagram to show how SiteLab fits in. I've circled it in red. And again, this idea that visualization doesn't need to necessarily be a solution in and of itself, but instead it can just be one part of a much wider kind of multi-product solution for your business. The example that we're going to look at for this one is, again, it's this concept of this Aurecon app ecosystem and how we can connect in real time to both BIM and also the FieldForce database, which is SharePoint. So if we go up to the extensions, we've got the first thing is the model information extension, and this is where we can basically, you can see that it starts to highlight objects, and then when you click on an object, it actually reveals all of that BIM information. You can do things like isolate and frame just particular elements. I think I isolate the chair. And again, it's pulling all that information straight out of our database. It's not baking anything in. But then the other extension that we've got is this asset management extension, and you can see that it's straight away it's loaded up the different assets that we've tagged, and you can see their condition on the right-hand side. And then when you click on each one, you can see if there's any sort of associated downloads for that particular asset. But then also you can look at the FieldForce inspection report itself, and it's all dynamic. If you update it in FieldForce, then it very quickly flows across into SiteLab. And it means that, again, you can start to look at visualization technology as a very intuitive and smart way of starting to tap into some very complicated databases. Okay, so I'm almost out of time, luckily. In conclusion, there's so much more to visualization than actually just visualizing. For us at Aurecon and Unsigned Studio, Unity's really given us the flexibility to completely change the way that we think about visualization, and in particular where it fits into the project lifecycle, and the hint is that actually it fits in everywhere. We're lucky enough to play in this really cool space that sort of sits halfway between engineering and visualization, the sphere of awesomeness. But really what that means is, we're creating real value through that project lifecycle. We're helping our clients actually achieve better outcomes. We're reducing their risk profile. We're determining the best solution. And what that's going to do, ultimately, it's going to result in better relationships with those clients for us. It's no exaggeration to say a big part of what we do is thanks to the power of Unity. So look, thanks very much, everybody. That's it.